This is a talk that has data from just about every single agency in our tech committee, so I thought I'd represent that by showing all of the different logos for all of our groups. There's actually, we haven't mentioned it yet, but there's been changes in our tech committee since the last State of the Lake reporting. There's been an increase in the number of tribal participants from the US side, and so I think I've captured everybody here. Not everybody that maybe could be on the committee, but these are all the agencies that have been contributing to our committee over the years. And this is certainly a group effort. So Lake Sturgeon has its own sort of working group underneath the technical committee, and so all the agencies are involved in our CSMI survey, and so this talk uses data from there, so I think everyone deserves recognition. Okay, fish community objective for Lake Sturgeon is pretty simple, like you've seen for walleye and for brook trout. It's to rehabilitate and maintain spawning populations of Lake Sturgeon that are self-sustaining throughout their native range. This isn't super helpful, so again, there was a rehab plan published in 2003 by the commission from work that was done in the late 90s, and in there they got into a little more detail about how to quantify what a self-sustaining population was. So in this plan, we define self-sustaining as a group of fish that ascend a common tributary to spawn in a given year, and that spawning population should at least be comprised of 1,500 mature individuals that are capable of ascending that spawning tributary, even though we recognize with the spawning periodicity of Lake Sturgeon that all those fish might not ascend the tributary in a single year. As well, we recognize, particularly on Lake Superior, but it's probably true for all of the Great Lakes, that we do have very small tributaries that sometimes house Lake Sturgeon populations, and it's not likely that those small tributaries will have the size, the habitat available to support that many spawning adults, so that we might have to adjust our goals and objectives for those smaller tributaries on a case-by-case basis. So I'm going to kick this off by showing you where we have Lake Sturgeon and where we've had them in the past. I'm going to have a figure here, and I have another one later that's similar, so I'm going to walk around the lake and show you what we know about Lake Sturgeon. So first of all, we have this sort of bright green color, and these are populations where we've had spawning animals in streams. They've been observed, and we've also collected either larval fish or eggs indicative of successful spawning and natural reproduction. So most of the work around the lake of recently has been done here on the Bad and White rivers, and so that's kind of where I start all of my figures. So the areas where we have natural reproduction are the Bad and White River, the Sturgeon River in Michigan, the Gooley River and the Batchewana River over in eastern Ontario, the Mishpicotton River, the Pick and White River, so there's two rivers close together in the northeastern part of the lake, the Black Sturgeon River, and the Kaministiquia River. The next group of rivers I'll talk about are ones where we've captured juveniles or adults. Sometimes we've even had adults in small numbers in the rivers, but we have no evidence of natural reproduction occurring. We just have animals either off the mouths of those tributaries or once in a while in them. And there we'll start with the Chippewa River. We have the Little Pick and the Prairie River, the Nipigon River, and then finally the Pigeon River on the border between Canada and the States. We have four populations that we consider to be extirpated. The Montreal River on the border of Wisconsin and Michigan, the Tequamanen River, the Gravel River, and then the Wolf River. And finally, we have two rivers where there's been ongoing stocking in order to support or reintroduce populations that have been extirpated. The first one is here in the St. Louis River estuary, and this river we actually have since 2011 evidence of those stocked fish reproducing. So this population was first stocked in 1983 and took till 2011, but those fish have grown up and started reproducing on their own. And then the second population where stocking is still occurring is in the Ontonagon River here, and this population was first stocked in 1988 and or 98? 98, thank you. I knew there was an 8 there somewhere. And we have not yet seen evidence of natural reproduction in that river, although we are probably getting quite close given the age of those fish. So that's my initial walk around the lake about what we know. I'm next going to move into relative abundance data. We do not have like many of the other species we've been hearing about in the last few talks, we don't have a lot of data, but we do have a few longer term data sets, one in Chequamegon Bay, another off the mouth of the Bad River, a couple of more recent data sets in Gooley Bay and Batchewana Bay, and then we have something that's still pretty recent. We only have 2 data points, but we do have a lake-wide juvenile survey that I'll spend a little bit of time talking about, where all of the historic spawning tributaries are being sampled, which is a huge agency effort, and coincident with the CSMI sampling every 5 years. So in Chequamegon Bay, this is a large mesh gillnet survey that occurs in the summer using 8, 10, 12, and 14-inch gillnets. The black line here is the catch in those nets. You can see catch per 1,000 feet. And the survey started in 1988 and has been ongoing since then. And you can see that there's this, particularly from the early part of 2000s to the last 10 or 15 years, this large increase in lake sturgeon in those large mesh gillnets. The blue line here is actually the number of lake sturgeon that have been harvested. There is a 1 fish per year fishing opportunity available in the bay, and you can see that typically that bounced around. It was quite high early when the fishery opened. It's been quite low at 1 to 4 fish probably per year for most of the time series, and then in the last few years there's been this spike in the number of fish being caught, and I believe that's a 50-inch minimum. I'm trying to remember, looking at the Wisconsin people. Yeah, so it's a large, again, targeting fairly large lake sturgeon in that fishery. If we move just out into the lake off the mouth of the Bad River, this is a much smaller mesh survey, so 4.5-inch gillnet survey, which is primarily targeting juveniles. Again, you can see that individual years bounce around quite a bit, but over the length of the time series from 1995, you can see a slow but steady increase in the number of small lake sturgeon being captured in this survey. If we move to the eastern part of the lake, a much shorter time series, this again is using now what we call our standard juvenile gillnets. These are the gillnets that all the agencies use during the CSMI survey. They comprise mostly 4.5-inch mesh, but some larger panels that can catch some adults or subadults as well. And so these nets have been fished in Gooley Bay and Batchewana Bay since 2010. And pretty flat relationships, but you're starting to see a small increase even over this short time frame in Gooley Bay, and a much more a flat relationship with the exception of 2017 in Batchewana Bay. Here's a bit of a confusing figure, but this comes from our lake-wide juvenile summer survey. So this is again the same gear I just presented for the Gooley and Batchewana River. This is all the historic tributaries. They're fished in the summer off the mouths of these tributaries. The 2011 data are the lighter colors, and the 2016 data are the colored figures. So obviously there's not a lot we can talk about with 2 data points, but there are some things here that I do need to probably get into or explain. So particularly on the south shore, and it's called the western unit here, but most of the populations in the southwest part of the lake were actually lower in our 2016 survey from the 2011 survey. And we think this is attributable to some very high water events that occurred in 2016. There were some huge floods, and typically we set these nets right off the mouths. Most of the effort is right off the mouths of the tributaries, and we think that the sturgeon simply were displaced in this period. So you can see some of these pretty key rivers for us, like the Ontonagon and the Bad, pretty severe declines. We don't think those are real. We just think, unfortunately, just happened to hit our 1 year in 5 that we sampled. We had these big floods. You see less of that in the other areas where the water levels weren't as much of an issue. The other thing I want to point out here is that we do have some pretty key populations, some very large populations. So the biggest of all is in the Gooley, but we also see large populations in the Pick River and the black sturgeon in Canada, and then off the Bad and the Ontonagon on the US side. So we have some populations that seem to be doing well, at least based on our juvenile index surveys. We only have one system where we have, well, it's a paired system where we have spawning population estimates, and you can see kind of the same trend there as you do from our other abundance estimates. the U.S. Fish and Wildlife Service did some mark recaptures back in the early part of the century, so from 2002 through 2004 in the Bad and White Rivers. So the White River is a tributary to the Bad River. And then they repeated that effort from 2010 through 2012 and 2015 and 2016. And if you squint enough, you can kind of see a slow increase again in the number of spawning fish entering the tributaries over this time frame. So again, everything I'm showing so far is good news in terms of abundance. I'm going to spend a lot of time on this figure. So this was a poster that was recently presented at the Lake Sturgeon coordination meeting we had down in Port Huron just a couple weeks ago. And so I asked the authors, this is Lauren Schumacher and Amy Welsh from West Virginia University, if I could actually borrow their data just to put on a slide, because I had some older genetic data. And I'm going to walk through this. It's not as complicated as it looks, but there's a couple interesting things here for sure. So within Lake Superior, we have 5 genetic units or populations. Sometimes they're individual populations, sometimes they're groups of spawning populations that show up as distinct genetic units. So we have the Kaministiquia River up in Thunder Bay. This one actually isn't a surprise because this is our only stream resident population. Most of the fish in the Kaministiquia River stay there all year round and don't go out into the lake. So this river has its own unique genetic signal. On the north shore of the Canadian side, we have fish from the Pick River, and then all the way over to the Black Sturgeon River. They show up as a distinct genetic unit. On the eastern part of the lake, we have, in green here, we have another distinct genetic unit from fish from Batchewana Bay and Batchewana River and Gooley River. On the south shore, on the U.S. side, we have the Sturgeon River, which is this blue, nice blue color, and then a little hard to see, but it's this white color here is again the Bad and White River. So another distinct genetic unit. In addition to those 5 Lake Superior genetic groups, we have 3 other genetic units that show up in Superior. We have a Lake Huron signal, which is in purple, and we have 2 signals from Lake Michigan, one from the Menominee River in red, and then another from the Winnebago system, the Wolf and Fox Rivers, in this darker orange color. And so when you look around the lake, so those are our kind of 8 genetic units that are distinguishable by this assignment process. When you look around the lake, you can see that for the most part, the fish are generally assigned back to where they're caught in terms of their origin, but almost always there are a reasonable number of fish that do not assign back to where they are. So if we start up in the northern part of the lake, so again, this corresponds to this black area, you can see that for the most part, these fish are assigned to this northern genetic unit, but certainly not always. In the Prairie River, we have a fairly large number of the fish that are being assigned to the Kaministiquia River, and then for some reason, Lake Huron. In the Mishpicotton River, which is in this corner here, the fish are equally split between this northern unit and this eastern unit, which fits very nicely because it's right in between the two. This middle row is fish from the eastern part of the lake, so from Batchewana Bay, Gooley Bay, and Whitefish Bay. And you can see for the most part, those fish are being reassigned back to that green color. But particularly in Gooley and Batchewana Bay, you start to see that there are fish from every single part of the lake being assigned to fish that were caught in those areas. And if you look again at our other key populations down in the south shore, you see that again. You see these little slices of color that are appearing, suggesting that there are fish being captured there that are being assigned to these other areas. So when you look at the south shore fish from the Ontonagon, the Keweenaw Bay, Sturgeon River, and Huron Bay, these fish are being almost always being assigned back to the Sturgeon River, as you would think. So the Ontonagon River, which is one of the rivers we're stocking, the source for those fish is the Sturgeon Bay fish, so that's why they're assigning back to there. Saxon Harbor out on Isle Royal has mostly South Shore fish with a few North Shore Canadian fish, so again, that probably makes sense. And then when you get to the western part of the lake, so starting at Grand Portage and then running around to the Apostle Islands, these fish are mostly being assigned to Lake Michigan fish, and that we can attribute to the fact that the St. Louis River stocking there was over 150,000 or so fish stocked there from the Wolf and Fox rivers. And so the genetic signal of those fish are showing up all over the western part of the lake. And I guess I shouldn't neglect the Bad River. So again, Bad River here and the Chiquaming Bay fish are mostly showing up as Bad River fish, but again, a pretty healthy chunk of those fish are showing up, are fish showing up from other parts of the lake. So this genetic data that we're collecting in conjunction with our juvenile surveys and also in conjunction with the stream surveys, I think is quite fascinating, and it's showing us just how much intermixing there is between these lake sturgeon. And that leads well to my next topic, which is acoustic telemetry research. There are 4 projects ongoing around the lake. I'm not going to give any real results today because they all deserve their own talks, but we have acoustic arrays set up in Black Bay, Whitefish Bay, along the Superior South Shore, and over into Duluth Superior Harbor. There's over 400 lake sturgeon swimming around with 10-year tags in them, and we're going to find, I think, a lot of very interesting information, probably which will support the genetic data that I just put up. We already know we have a few of our tagged fish that have undergone some pretty long distance migrations. The objectives for this telemetry work are pretty similar across all the projects. People are interested in understanding the timing, frequency, and magnitude of movements between the tributaries and the lake. So again, these fish spend much of their summer out in the lake, but they run into the streams in the spring to spawn. Coincident with that, we're interested in assessing the historic spawning tributaries. So again, there are populations that are extirpated or at very low levels, and we're trying to figure out if sturgeon are still using those systems or not. And then we have a bunch of ecological things we're looking at. We want to find things like home range and critical habitat for feeding, overwintering, and spawning periods. Some of these fish have sensors in them, so we can look at things like preferred depths and preferred temperature strata. And lastly, this is particularly important in the western part of the lake where we have all those stocked fish that came from Lake Michigan. People are interested to see if these patterns that we're seeing are potentially related to the genetics of those fish. And so over the next 10 years, we're going to find out a lot about lake sturgeon. Wanted to quickly touch on rehabilitation stocking. As I mentioned, we had 2 major rivers that have pretty intense stocking programs. One of them is historic in the St. Louis, but the one in the Ontonagon is still ongoing. I wasn't able to put the full data series on, but for the first up to through 2010, these fish were stocked out of sort of traditional hatchery fish. So in this period, since 2013, we've gone to a streamside rearing trailer, and so all those fish have been reared streamside before they're being stocked in the lake. And as you saw from our juvenile surveys, off the mouth of the Ontonagon, we have pretty high densities of lake sturgeon. So I would say that this is, stocking exercise has been quite successful, and we'll probably see the fruits of that in the next couple of years when the first fish show up to spawn. So I'm going to end my data part of my talk by showing you what we think we know now about these populations in terms of their recovery. Have we met our self-sustaining objectives for these populations? And it's similar to my first graph. I'm going to walk around the lake. The light green are fish that have recovered, and we only have 4 areas where we think we meet that self-sustaining criteria. Again, in the Bad White River, the Sturgeon River, the Gooley River, and the Pick River. We have a number of populations that are recovering, so these are where things are trending in the right direction. We're seeing more fish, we're seeing solid recruitment and lots of younger fish, and that includes in the St. Louis River, the Ontonagon River, those are our 2 stocking rivers, the Batchewana River, the White River in Ontario, the Black Sturgeon River, and the Kaministiquia River. Unfortunately, we have a number of populations that, despite a lot of effort, remain at very low abundance levels, and we would consider these populations to be still vulnerable, or extremely vulnerable, some of them. Those include the Chippewa River, the Mishpicotton River, the Little Pick and the Prairie River, the Nipigon River, and the Pigeon River. And then, of course, our extirpated populations, they're still extirpated. So, just as a synthesis, I would say that we've achieved our objective in a few spawning tributaries and made good progress in others, but approximately half of our historic tributaries remained vulnerable or at very low levels. And so overall, our FCO remains only partly achieved. I just have a couple of very simple recommendations. I think it's important that the agencies continue to support our CSMI survey every 5 years. It's going to continue to provide very valuable data for us into the future. For those vulnerable populations where there are still existing sturgeon populations and we think we can make a difference, we need to identify and mitigate the limiting factors or threats. And there might be a couple of cases on that list of extirpated populations, again, where now that we know we can successfully stock lake sturgeon and recover populations through conservation stocking, that we might want to consider doing that in at least a couple of those extirpated tributaries. Just want to thank everybody that contributed actual data to this talk and their agencies.